Hello everyone, today I'm going to show you how to use the fundamental theorem of the calculus part 2 or FTC II. As the fundamental theorem of calculus part 2 states that if a function fx is continuous in AB and ax is written as function ft integration from a to x, then we can have ax derivative equals fx. Here we should emphasize that the lower limit a should be constant and the upper limit x should be single variable. For example, ax equals t power of 4 plus 1 and power of 1 divided by 3. Integration from minus 5 to x. Then we can have ax derivative equals x power of 4 plus 1 power of 1 divided by 3. In this case, we just use x to replace the t, so we can get the ax derivative. If we want to get function derivative at x equals 1, then we can use 1 to replace x, so we can get ax derivative at x equals 1 equals 2 power of 1 divided by 3. However, if the upper limit is not a single variable, such as gx equals integration from minus 5 to x power of 3, in this case, we can treat x power of 3 as a single variable. Then we can do the derivative on this part, just like a compound derivative. So we can have gx derivative equals x power of 3, then power of 4 plus 1 times 3 times x power of 2. This is the derivative for the x power of 3. So if we want to get the derivative at x equals 1, then we just replace x with 1. So we can have the derivative at x equal 1 equals 3 times 2 power of 1 divided by 3. However, if we have the case for the both lower and upper limits is a function of x, such as gx equals integration from minus x2 to x power of 3. In this case, if we want to use FTC theorem, we have to rewrite this integration. So the gx integration can be written as two parts. One is from minus x power of 2 to 0, and another part is 0 to power of 3. Then we can change this lower limit to the upper limit. So we put a minus in front of this integration. Now we realize that for this part, we can use the FTC theorem. And this part, we can also use FTC theorems. So for the gx derivative, we can use this minus x power of 2 to replace t. Then perform the derivative on this part. Similarly, we can use x power of 3 to replace t. Then do the derivative on x power of 3. So after simplification, we can get the gx derivative like this. Then if we want to calculate gx derivative at x equals 1, then we just replace x with 1. So we can have gx derivative at x equal 1 equals 2 power of 1 divided by 3. So that's all for today. Thank you for watching.